So about 95% of our electricity at the moment comes from non-renewable forms of energy. This is the fossil fuels, coal, oil and gas, and nuclear energy. What we need to do is to talk about those a little bit, and most importantly to compare the advantages and disadvantages of each one, and also to talk about what's called CCS. So we need to have just a few definitions so we can talk about these things first. First one is startup time. So this is when you've got a power station, it's not actually producing electricity. This is not to do with building it, this is just it's all built, it's running, it's ready to go, but you're not actually using it at that time. How long will it take if you say, oh, we're going to have some cold weather? Can you get that power station going? That's called a startup time. Capital costs, this is the amount of money that you have to spend when you build a power station. The running costs, the amount of money it costs you to buy the fuel and pay the people to run it once you've built it. And decommissioning costs, this is the cost of knocking it down after its life has run out. All power stations really have a maximum life when everything starts to wear out, and then you have to decommission them. So here's some data on these things. Obviously there's lots of variations in this sort of information, but this is the kind of data you might get in an exam to just have a look at. If we think about the best resource for each one, so here's our capital costs, our building costs. You'll see nuclear power stations are the most expensive to build, gas power stations are the cheapest. You save a bit of money because you haven't got to grind it all up and do those things that you have to do with coal. Running costs, these will change a lot, but you'll see nuclear is certainly the cheapest one to actually run. It was far and away the most expensive to build. Gas at the moment might be a bit cheaper than coal, although that might change as the price of gas increases as it starts to run out. CO2 production is a crucial one we'll talk about. So nuclear power stations don't produce any CO2 at all, apart from the actual building costs of making the power station in the first place. Once it's running, it's not producing any carbon dioxide. Decommissioning cost is a bit of a killer for nuclear power, because there's a huge cost involved in getting rid of all the radioactive stuff that's left at the end. Gas and coal relatively cheap. Once the power stations are worn out, you can just knock them down. Startup time is also very bad for nuclear. Okay, gas is much quicker. You just almost kind of can say, get it going, we need it tomorrow. The weather forecast not very good, we'll need some more electricity. Nuclear power stations need a couple of weeks at least to get going. So they're not very flexible, and really the nuclear power stations we have at the moment have to run all the time that they can run, and the gas is used as a kind of flexible top-up. Available reserves, this is quite good for nuclear. Coal, there's quite a lot of reserves. Gas, we're burning it much quicker, and we've really burned nearly all of the gas that we've got in our own supplies, and the gas that we burn now in this country is mostly bought in from Russia and from Scandinavia. But the thing you have to look at for an exam here is just to be careful that sometimes a high bar is a good thing, whereas sometimes a low bar is a good thing. Obviously you have to use a little bit of common sense to work out which you're looking for. So this is a little summary of the advantages and disadvantages. So coal has got large reserves, but it does produce the most carbon dioxide. That's why coal production of electricity has gone down a lot in this country in the last few years. Gas has got the shortest startup time, so it's very flexible, but it does produce carbon dioxide, but only about 2/3 as much as burning coal for the same amount of electricity. But the cost of gas is going up quite rapidly because it's such a great energy source. There's a lot of demand for it, and the cost has gone up quite a lot in the last few years, and probably will go up a lot more as the supplies start to run out. Nuclear's got a lot of good advantages. So it's got the biggest available reserves, it doesn't make any carbon dioxide, it's got the lowest fuel costs, so all those things seem great, but it's the least flexible one. It's got the long startup time, it's got very high decommissioning costs, and then the two things that make nuclear power so controversial: it does produce radioactive waste, there's nothing you can do about that, and people aren't very clear about what to do with some of the waste that's produced. And then, of course, most crucially of all, there is that possibility of a major accident which could kill thousands of people in one go. So obviously the accident at Chernobyl and the accident at Fukushima, those have made a lot of people very dubious about the wisdom of building nuclear power stations. So a possible solution to these problems is CCS. Okay, our problem here is that there's huge reserves of coal, but people are trying to stop us using coal at the moment because of global warming. So the solution to this may be to capture the carbon dioxide and just bury it under the ground. So a simple idea here is, here's the power station, it's making CO2, you just capture that CO2 and you pipe it down into this hole in the ground where you've just got all the gas or the oil out of previously. So that makes it look really, really simple. This is called carbon capture and storage. It's carbon as in carbon dioxide, capture it and then store it somewhere rather than letting it out into the atmosphere. This seems like a really great idea and it's possibly the solution to all our problems. However, it's actually very difficult and nobody's really got it to work yet. Actually capturing the carbon dioxide is very, very difficult to do.